Very good evening to everyone. First of all, I would like to thank the organizing committee and chairperson for giving me an opportunity to present my research paper here in this conference. Let me introduce myself. My name is Nikhil Kumar. I am student of BSc Non-Medical final year from ST College, Barnala. As you can see on the screen, my topic of presentation is thermophysical properties of neodymium nitride under high pressure of first principle study. The outline of my presentation is as follows. From the survey of literature, we found that sufficient experimental data are available on neodymium nitride with less theoretical work. Neodymium nitride is used for a variety of technological applications, like in the field of spintronics and as a fuel reactors. Today, I'm going to be reporting on the results of the study we have carried out. Here are some general properties of neodymium metal. Neodymium is a rare earth metal with the atomic number 60, electronic configuration xenon 4f46s2. It is bright and having silvery metallic luster. It combines with nitrogen to form a blackish powder neodymium nitride. Now coming to the theory part, Schrödinger wave equation first principle approach. In physics, a calculation is said to be from first principle if it relies on the basic and established laws of nature without any additional assumptions or special models. All the information of a system is contained in system's wave function, and this wave function for a single electron moving under the potential V can be calculated by using Schrödinger wave equation. Here the first term is the kinetic energy and second term is the potential energy of the electrons, and the E is the energy eigenvalue. Now suppose if there is a many electron system, then how can we solve the Schrödinger wave equation? So the problem extending to the more electron system, Born-Oppenheimer approximation is to be used. According to Born-Oppenheimer approximation, the wave function of a many electron system is a function of electrons as well as its nuclear coordinates. The motion of electrons and nuclei are coupled. However, nuclei are much heavier than do the electrons, so they consequently move slowly than do the electrons. So we can differentiate the motion of electrons and nuclei. So using Born-Oppenheimer approximation, Schrödinger wave equation can be written like this. Now coming to the density functional theory. In quantum mechanics, the total wave function of a system depends upon the all the electrons present in the system, and they cannot be decoupled as a single electron because of their mutual interaction. So the problem is still far too complicated to be exactly solved in practical computation. So to overcome this problem, further developments are required. DFT provides the
results.
Okay, sir.
Because yes.
Okay, sir.
थोड़ा सा एनटीए और इसके जीजे और थोड़ा बता दें.
We have used GGA approximation for the calculation of exchange correlation potential and exchange correlation energy, because this provides better results as compared to local density approximation. So coming to the, we have used Gibbs program for computing various thermodynamic properties of solids using energy curves using a quasi-harmonic debase model.
What you have calculated?
Yes.
Your calculation.
Yes. Okay. Let's have a look at the graph showing the variation of unit cell volume of neodymium nitride compound with respect to pressure and temperature. The unit cell volume of neodymium nitride decreases exponentially with the corresponding increase in pressure. But in the second case, where we see the unit cell volume of neodymium nitride compound increases in a very small amount from 0 to 300 Kelvin. But after this, the value of unit cell volume increases very sharply with the linear curve. Here the graph showing the variation of bulk modulus with pressure and temperature. When no pressure is applied at any fixed temperature, the value of bulk modulus remains near about 100 to 110 10 gigapascal. This value increases linearly with the corresponding increase in pressure. And in the second graph, the value of bulk modulus decreases very insignificantly over a wide range of temperature. And at any fixed temperature, the value of bulk modulus is higher corresponding to the lower pressure. We have tabulated the various thermodynamic parameters that we have calculated in this table. That is unit cell volume, thermal expansion coefficient, bulk modulus, its pressure derivative, specific capacity at constant volume and pressure, Grunzian parameter, and debased temperature. Our calculated value for debased temperature is 413.39 Kelvin, which is in well agreement with the previously reported experimental value, that is 410 Kelvin. So this brings me to conclude my presentation. The calculation have been used using DFT and Gibbs code. We have used GGA approach for solving the correlation functionals. We have calculated the various thermodynamic property as we have discussed in the previous table. Our calculated value for debased temperature is for neodymium nitride is 413.39 Kelvin, which is in well agreement with the previously reported experimental value 410 Kelvin. This work can further be extended by implementing or analyzing these as well as few more properties of other lanthanoids. In view of recent experimental success to grow such compounds and their relevance to the field of technology, we believe that our work will add to the understanding of this system, but also contribute to the future experimentals. I'm very grateful to the Department of Biotechnology, New Delhi, for providing me financial support to present this paper under DPT Star College scheme. I would also like to thank my mentor, Dr. Sanjay Kumar Singh, Department of Physics, ST College, Barnala, for their guidance and support. We have some references which are given here. Thank you. If you have any questions, please ask.
कौन सा लिया आपने सॉफ्टवेयर क्या कौन सा यूज किया आपने कोड
सर गिब्स कोड वी हैव यूज्ड गिब्स कोड
यूज किया है
यस
तो इसमें ग्राउंड स्टेट कैलकुलेशन है या फिर एक्साइटेड स्टेट भी है
सर ग्राउंड स्टेट प्रॉपर्टीज वी हैव कैलकुलेटेड ग्राउंड स्टेट प्रॉपर्टीज
तो इसमें पैरामीटर्स आपने चेंज किए हैं बाल क्या मॉडल में तो क्या एबीसी करें क्या करें
कैसे सर
पैरामीटर्स कुछ वेरी कराए होंगे ना आपने मिनिमाइज तो कराए होंगे ना
यस सर
तो कौन से पैरामीटर मिनिमाइज कराए आपने
सर गिब्स फ्री एनर्जी मिनिमाइज करें
Any question, anyone?
Any other software in comparison to Gibbs? Any other software?
I'm just learning these all things because I'm in BSc class.
So you are in BSc?
Yes, sir.
Very good. That's very good. Thank you very much.
Thank you, sir. Thank you.